I'm Meir, and I'm going to be talking about Pythonly. So what's Pythonly? It's a notebook-based data science learning platform, meaning like Colab, JupyterLab, but based on Blockly. And it's meant for high school and college students. There are some pictures from the last workshop I did in Pokhara, Nepal. 10th grade students. As you can see, in some cases they don't have access to the computer lab, although they have the computer lab, but because they have only one in such a big school, then sometimes you just need to give lessons without any computer. So you didn't like simulate everything on a notebook. I mean, a paper notebook, not a notebook. Okay, so everybody was talking here today about AI, almost everyone. Why not just build a model? And we can get some inspirations from existing models, although they are a bit with big numbers of parameters. We are going to build a single neuron model. Here's a kind of example that can be solved with a single neuron. Given data that composed of just dots we need to find the linear equation, the line that they originally came from, perhaps with some noise. So this is the model. We have a single input with two parameters, the weight and the bias. And this is the function, quite simple function. Now I have a question. How fast can you type this expression in Blockly, including creating the variables? It took me about 50 seconds, between 50 seconds to 1 minute to write just this expression. And what about this one? This one takes about between 2 to 3 minutes to write in Blockly. So this is quite frustrating for students that are not in primary school, but in high school or in college. It seems like something is, there is some friction. Okay, so here is an example of a function. By the way, we use a lot the plus-minus concept for famous plus-minus extension. And this is how it's written in Pythonly. An expression, a math expression, with just plus minus. And that was a function that returning a variable. So you saw here two concepts in Pythonly that quite make it smooth to work with variables, with expressions, and with functions, as we'll see again. Okay, so here's our single neuron model. This is the function that implements this neuron. By the way, notice the comments in Pythonly. They are visual, they are visible. They are not hidden inside the block. It's mandatory. And this is the error function, the loss function. And in Pythonly, you can also embed images and diagrams and drawings inside the code. This equation, it's an image that was embedded inside the editor. Single neuron models are really highly recommended for teaching data science, especially for beginners. You can make many interesting things with single neuron model, like a spam detector model. So this spam detector, for example, accepts the word counts as the inputs and the weights as the list, and just calculates the same equation like we saw before, but now with many more inputs and many more weights. Note that this is still solvable using a single neuron, as long as this is a multidimensional space. As long as it's linearly separable, it's doable. Okay, so when I built Pythonly, I had these requirements in mind. It was supposed to be low floor, high ceiling. Low floor means for beginners, and high ceiling, anything above that, like 6 months or 1 year of working with Blockly, Pythonly. Simplified data science coding, a visualization of both the data and the code, and to have an environment that is kind of experimental, a sense of a lab. And above all, to have a data agency. That means that students can own their own data, can build their own data, and build models on their own data. That changes the picture quite a lot. The next important thing was fluid coding, because these were college students and high school students. So expressions, variables, functions all need to be smoothly edited. Workspace need to be scalable. If you want a notebook, that means that every cell has its own workspace. We wanted a seamless statement input. We want, whenever it's possible, whenever blocks can be either statement or either input, it could be quite simple to toggle between them. And we wanted also seamless blocks to code. And lastly, because this is a data science application, it needed a lot of APIs like Pandas, NumPy, Mosaic, and many more. So I needed to support lots of APIs, and there was no way I was going to write all this code using the regular Blockly block definitions and generators. That's in addition to having it a multi-language execution. At least 2 languages that we needed, R and Python. And one more feature that I thought would be interesting and very usable for teachers is to have the ability to draw, to involve to a mixed drawing within the workspace, mostly for documentation and for explaining what's going on. So I want to show the 3, these are the actual design decisions. As I said, it's a notebook, and not only that it's a notebook that in the sense of pipeline, notebooks work as a pipeline. You run cells, and each cell is executed after the last cell you executed. So the execution is actually dependent on the order in the order of the execution. And within each of the cells, we also imply a pipeline. I'll show you immediately a demo of what it means. The editor is a structure editor, meaning statements and inputs we can switch statements and inputs quite easily. There is a variable scaffolding block editor. We have inline block editor in addition to code to blocks and blocks to code. We can edit blocks inline. And we extended the plus minus concept to many, many other blocks. For the integration part, we support, as I said, Python and R. We use something that I'll immediately explain. Let's see first the demo. So this is the first cell. We just draw what we're going to do. We want to build a machine to recognize drawings. And for that, we're going to go to the data section of the application, and there's the quick draw, which is based on Google's it's a massive repository of images drawn, hand-drawn by users all around the world. This is how the data set looks like. It's editable. You can edit, you can delete lines, you can add lines. Back to the editor, we select the quick draw data set. We add a splitter to be able to do some testing. And then there is a classifier where we select the type of classifier. And then we call a method of the object that we will get from the classifier, in this case, the get score. Toggle it into an input and print that to the output. And now you can see the code generated. Let's try to run it. And we get an error, of course. The variable myClassifier was not yet defined. So we click the icon left to the classifier block and automatically generated a variable inside the block, but this is actually an assignment. Now we create another cell just to make a prediction. First, we print few rows from the table just to get the sense of idea how it looks like. And then we create another method by clicking the MPIL plus MPIL. We select the predict, cut and paste it into these cells and wrap it in a print block. And now we see the prediction. You see the real targets, the real results. With one error, we have about 80%, that's the score, so that makes sense. But we can also do a really nice thing, and instead of using the same data for a test, we can draw a picture and hope that the model will recognize the object. That's a cute cat. And it does recognize the cat. I will just show this demo for the structured editor. In this case, we have the same function as before. This time, we add an assignment to a global variable, to y. And this time, the y is not returned from the function, but the intention is to change the global y. Now we call the function. And if we try to print y after we call the function, it's going to be very surprising. We get 0 rather than 5. And the reason is that in Python, the local variables are local, they're not global. You need explicitly to specify that they are global. Last thing, for the integration, for the extensions, as I said, we have many APIs to implement. And for that reason, I defined a basic scheme. It's called the ABS scheme, API block scheme, that actually use Blockly like an assembly. We don't handle any inputs, any fields. And when writing all these APIs, there was no single block definition and no single for block generation. So this all magic happens using this level, which is actually an API JSON definition. That makes the whole thing of supporting API, supporting languages quite way simpler. And that's about it.
Thank you.